In the previous video we had a look at concentration time graphs. What we're going to do now is move on to rate concentration graphs. So like I said before, when you hear a title like that, rate concentration, it tells you that the first thing is on the y-axis and the second thing is on the x-axis. So how does the rate vary as we change the concentration? So what we're going to do is look at the different orders again, and we're going to look at the shape of the graph. Okay, so we're going to be looking at how rate is related to concentration with different orders. So if we have a look at how we would label our axes, we've got rate in moles per decimetre cubed per second and concentration in moles per decimetre cubed. What we need to think about is, what does zero order mean? Now remember that the rate equation would go rate equals k a to the 0. Now if you put a to the 0 into your calculator, what you get is the number 1, so rate is just equal to k. And that, what we're saying there is that the concentration of A has no effect on the rate. The rate is independent of the concentration of A. So have a think about what that means and what that graph might look like. Okay, so rate is independent of concentration A. Rate is just equal to a constant K. How would you draw that? It doesn't matter what the concentration of A is, you're just going to get the same value for rate. It's going to be the value of the rate constant. See if you can have a think what you'd plot that like. So there you go, it's a straight horizontal line. Rate is independent of concentration of A. It's just equal to the value of the rate constant. Okay, so what do we mean if something's first order with respect to A? So just pause the video again and label your axes. So there we go, we've got our rate up the side and our concentration of A along the bottom. And here remember, if our rate equation was something like rate equals k a to the 1, k is just a constant, so what we can say is that rate is proportional to the concentration of A. So what would that look like? So it's our y equals mx graph, but there is no plus c, so where does it cross the y and the x-axes? So we should have a y equals x kind of line there. So what does that mean? If I were to double the concentration of A, what would happen to the rate? So what that means when something is first order is that if I were to double the concentration of A, then I would double the rate. If I was to times the concentration of A by 10 times, it was 10 times as concentration, the rate would be 10 times. That's what directly proportional means. So rate is directly proportional to concentration of A. So pause the video again and have a think what you might think a second order would look like. So I've put my axes on, and what we can see is that if rate is equal to k times the concentration of A, which is second order, so A squared, then rate is proportional to A squared. And what you might have done is at GCSE you may well have drawn a graph of y equals x squared, and it would have actually looked like the reflection of this. You would have had the whole of the U shape, but because we've only got the positive values, we've only got this side, we haven't got the other side into the negative concentrations. If we wanted to confirm it was this, and that might be useful if you know what a y equals x cubed graph looks like. It looks very similar in the positive half to this, so we might want to confirm that it's a second order graph. We could plot on the bottom, instead of just concentration, we could plot concentration squared against rate, and if it is second order, we'd now get a straight line because rate is proportional to A squared if it was second order. So these are rate concentration graphs, and we need to be careful that we don't muddle these up. These are perfect for use in multiple choice questions because you can mix and match the different types of graphs and see who really is paying attention. So what I want you to do now is take a couple of minutes and have a look at this question on the next page. I want you to pause the video, I want you to have a go at the question and then come back and have a look at the answers. So if we have a look at this, it tells us in experiment 1 that B is varied, and if we look at that line, since that line is horizontal, the rate is independent, it's not changing when we're changing B. So if rate is independent of the concentration of B, that tells us that B is zero order. And if we look at experiment 2 where A is varied, we can see that that is a directly proportional line, and so rate is proportional to A, which makes it first order. Now remember that our rate equation always has the form of rate equals K times the different concentrations. What we can see here is that because we had A was first order, we put A in square brackets with the power 1, which we don't need to show, and B was 0 order. Anything to the power 0 is the number 1, and therefore we don't need to put that into our equation. Then it says, what would happen if A is doubled? Well, if A is doubled, since A is first order, rate would go up 2 to the power of 1, because A was doubled, that's times 2 for A. It's first order, so that's to the power 1. And 2 to the 1 is 2, so rate would be times 2. If B is tripled, since B is 0 order, anything to the power 0 is the number 1, so the rate would just be multiplied by 1, and that means it's not changed. That's our very short video on rate concentration graphs.